So let's take a look at Part B-1 of the January 2019 Chemistry Regents Exam. Now I broke it up into Part A and Part B-1 for a reason, because Part B-1 now with the Chem Regents we have questions 31 through 50. So we're still dealing with multiple choice, but now what you have here is problem solving, either mathematical equations, you might have to read a table, maybe a graph. So Part A is about facts and definitions, and Part B is more about calculations. So let's get started. So let's take a look. Alright. Question 31, we have nuclides. Nuclides mean isotopes. It's another word for it. So uranium-233, 235, 238, they're all isotopes because uranium has the same number of course now I just blocked it, protons. Alright, but it's different number of neutrons. So while I just got through saying questions 1 through 30 are about definitions and facts, sure enough, question 31 is really another fact. Or, again, the fact and then a definition of isotope. Let's move to 32. Here we have a chart about diamond and graphite. You're dealing with two forms of carbon, meaning the bonding or arrangement of carbon atoms, and diamond and graphite have different properties, and the reason why they have different properties, real simple, different structures. They're both solids, so we call that crystal structures. Next question, 33. Given the equation represented, reaction is classified. Well, what do we have here? We have a compound and a compound, so two compounds on the left and two compounds on the right. This is known as a double replacement reaction. There is decomposition, synthesis, single replacement, double replacement. You need to be able to look at the pattern and know the difference. And this one, two compounds you start with, two compounds you end with. That's double replacement. Alright, on to the next page. Good idea to run through the questions yourself. You can look up any Regents exam for any subject if you just Google New York State Chemistry Regents Exams and it'll come up. Okay, so if we look at question 34, iron 2 oxide. Alright, so now we're finally getting into more problem solving. So to know the formula for iron 2 oxide, you need to keep in mind that the Roman numeral tells me the charge for the iron. It's +2, oxygen, look it up on the reference table, is -2. Since it's 2 to 2, it's 1 to 1, and the answer is choice 1. For 35, how many moles of KClO3 must completely react to produce 6 moles of O2? This is, for 35, a mole stoichiometry problem. You only have to worry about mole problems, and it's real simple. You have 6 moles of O2, and you're looking for the moles of KClO3. It's a 2 to 3 ratio. In other words, x over 2 is equal to 6 over 3. Solve for x. 3x is equal to 12. X is equal to 4. You're going to divide both sides by 3, so the answer is choice 4. Let's take a look at 36. What is the number of moles of CO2 in a 220 gram sample of CO2 with a gram formula mass of 44? Okay, so for this question, we're looking for moles and we're given mass. Don't forget, you have equations. If I keep flipping here, there we go, reference table T, mole calculations. So moles is equal to mass over gram formula mass. You don't even have to calculate the gram formula mass here. It's 44. So again, Let me first erase all of this. It's moles is equal to 220 divided by 44. Okay, when you use your calculator and you plug that in, you're going to get an answer of 5 moles. For 37, you have a solution. It contains 25 grams of KNO3 dissolved in 200 grams of water. What is the numerical setup that can be used to calculate the percent by mass of KNO3 in the solution? Okay, so percent by mass again. Check out reference table T. Here we go. So percent composition by mass, right here. The part, that's what you're interested in, that's the percent divided by the whole thing. So let's go back. Now we're just looking for the setup, which is the numbers. So for something like this, the part is the KNO3, and then the whole thing is going to be the solution. So this is where they're going to try to trick you. It's 25, which is your solute, which is your part, over solution. Remember, solution is solute plus solvent. So it's not 25 divided by 200 times 100. It's 25 divided by 200 plus 225, or 225 times 100. So that answer is here in choice 3. Because remember, a solution has 2 parts, the solute plus the solvent. Let's go on to 38. Okay, we're looking for molarity. We have a half liter of aqueous solution that contains 0.2 moles of NaOH with a gram formula mass of 40 for NaOH. So molarity, the symbol is capital M. Again, we're doing a calculation. So let's check reference table T. And sure enough, here's the molarity equation. Moles of solute, that's what's being dissolved, divided by liters of solution. So let's go back and take a look. Does it make sense? Well, we have molarity is equal to moles of solute over liters of solution. So we have 0.2 moles of NaOH, and the solution is 0.5 liters. So 0.2 divided by 0.5. So the answer is going to be, when you plug it in your calculator, always use your calculator, is 0.4, or choice 4. Question 39, we have a table. This is properties of ethanol and water. So let's take a look at the question. Which statement describes a property of ethanol after being separated from the mixture? So it would have been a mixture of ethanol and water. And we're looking for a property of ethanol. I'm assuming from one of these. Remember, a mixture means they're physically combined, so they keep their own properties. So the first is ethanol non-flammable? Well, that's not a property of ethanol. It is flammable, so we'll cross that one out. Next is ethanol has a melting point of 0 degrees. No, it's got a melting point of negative 114. Cross that one out. Ethanol has a density of 0.8 grams per centimeter cubed at STP. Well, look at that. It matches the table, and there is our answer. The last one is that it has a boiling point of 89. No, it has a boiling point of 78. We already found our answer, which is choice 3. The other ones don't show up on the table. Move to question 40. We have a rigid container. It has a movable piston. It contains a sample of hydrogen gas. 330 K. Remember, 330 Kelvin means temperature. Okay, it has a pressure, that's P, of 150 kPa, kilopascals. And we have a volume of 3.5 liters. That's V. We're asked, what is the volume of this sample at STP? Remember, STP means standard temperature and pressure. If you forget or you don't want to guess, here they are. Standard temperature and pressure. So since we're dealing with kPa in the problem, we would use kPa, and remember with gas laws you're always using Kelvin. So let's go back. The other thing is we're dealing with a gas, and the only gas law equation that you need to know for the Regents exam is this combined gas law. It's a combination of Charles Boyle's and Guy Lassaic's law, and that's the only one you're going to have to worry about. So let's go back and let's use that. So we have our variables here. Let me go ahead and erase some of this. Oop, I don't know what happened. I went a little crazy. So we can go ahead and lay out this problem here. Alright, so my suggestion always, even with multiple choice, is to write out the equation. So it's P1, V1, T1 is equal to P2, V2, and T2. So our initial conditions, we have a pressure of 150 kPa. The volume to start was 3.5. Our temperature was 330 Kelvin. On the other side, STP, my pressure in kilopascals is 101.3. I'm looking for V2, and my temperature is 273 Kelvin. So now you need to solve for V2. So of course you can cross multiply and divide. When you plug it in the calculator, cross multiply and divide, you get an answer here from choice 2, which is 1.96 liters. Okay, so for the next one, we're dealing with a numerical setup, which just means you're plugging into the equation, and we're dealing with heat energy to completely melt 100 grams of water at 0 degrees. Well, if we're going to melt water, or melt anything for that matter, we're going to go back to our reference tables, and now what are we dealing with? We're dealing with heat. But if we're dealing with heat and we're dealing with melting, we're dealing with fusion. So we are dealing with Q is equal to MHF. There is no temperature in the equation because temperature is being held constant at a phase change. So when I go back to the equation here, or to the setup rather, we need to plug the numbers into the right equation. So it's Q is equal to MHF. Alright, and it's for water. So even though they give you temperature, you're not going to plug it in because temperature is remaining constant. We have a 100 gram sample. Okay, so that we know. And then heat of fusion, where for water, don't guess. Take the reference table, go to reference table A. Let's find it. And here it is. Heat of fusion, 334 joules per gram. So sorry for the flipping back and forth here, but you should be doing this too. So 334 joules per gram. So this is my setup. It matches choice 1. For 42, we're looking at during which phase change does entropy of a sample increase. Entropy is the amount of disorder or randomness that goes up or down depending on the phase. So an easy way to figure out these problems here is to just write S, L, and G, and then go ahead and look at the phase changes. So for choice 1, it's water as a gas going to water as a liquid. So if I draw that arrow, gas to liquid, this was choice 1. For choice 2, I have gas to a solid. For choice 2, if I go to choice 3, liquid to gas, choice 3, and finally for choice 4, liquid to solid. So you'll notice that 3 of the arrows are going to the left, and only choice 3 is going to the right. So that's the answer. And I think you would agree that it makes sense that the randomness or disorder is going to increase when I have a liquid and now the particles go into the gas phase. They're further spread apart, so that, again, there's more randomness or disorder. So the answer for 42 is 3. Alright, we're almost done with the 50. Let's take a look now at the next page. So we're given this formula, and we're asked what's the chemical name. Okay, so this is an organic compound, meaning it's a carbon-containing compound, and we want to take a look at what's different with this compound. Well, carbon is part of an organic compound, hydrogen's next, then anything else, and you'll notice that there is nitrogen. So let's go to the reference tables, and if we come here to table R with our groups, we're looking for compounds that contain nitrogen. As you go down, there's only 2 classes of compounds that contain nitrogen. Now, the one that is part of the compound in the question is going to be an amine. It is not an amide because it not only would it have carbon, it would have oxygen. We don't have that. So it's amine, A-M-I-N-E. So let's go back and take a look at what we have. So it's either going to be choices 3 or 4. It's not going to be choices 1 or 2. Then it's either 1 butamine or 4. The but comes into play because there are 4 carbons in the molecule. Okay, and then the 1 or the 4 is where the functional group is. And you always go with the lowest number, so you count the carbon chain from right to left and left to right. So the best answer for 43 is choice 3. Let's take a look at 44. For 44, we have an organic reaction. So just like we need to know the 4 inorganic reactions, which is synthesis, decomp, single replacement, double replacement, for organic, there are reactions that you need to be able to recognize, including these 4 choices. What we have in the equation is we have a hydrocarbon, more specifically an alkane and a halogen, and you'll notice there's a switch or a swap between one hydrogen and one of the chlorines. That is known as substitution. So as far as types of reactions, it's pattern recognition. You have to go back and memorize those patterns. Take a look at 45. For question 49, we're dealing with half reactions and we're looking at reduction. So if we're looking at reduction, remember that's the gain of electrons, which is reduction. If we have the gain of electrons, we're going to see electrons on the left side. So right away you can cross out choice 1 and choice 4. Now remember, with redox reactions or half reactions, you have to balance in terms of mass and charge. It cannot be choice 3 because I can't have silver, right? Gaining an electron and becoming positive. That makes no sense. So it's not choice 3. So the only answer it can be is choice 2. Moving to 46, we have a balanced ionic equation here. And here it is. Now this has the spectator ion, the negative ion, taken out. So it's asking us to describe the electrons involved with the reaction. We're starting with zinc as atoms, so the oxidation number is 0. For cobalt, +2, because the ion charge is the oxidation number. Then zinc becomes +2 on the right-hand side, and cobalt as the atoms is 0. So we just need to describe that in words from our choices. So we have zinc, the oxidation number going from 0 to +2. If it's becoming more positive, that means the zinc is losing electrons, which is oxidation. So zinc is losing 2 electrons. So it cannot be choices 3 or 4. At the same time, if something's losing, something's gaining. So the cobalt 2+ is gaining 2 electrons. And that's going to be choice 1 for 46. For 47, this is a pretty tough question. You're asked about oxidation states for nitrogen. Well, you have two nitrogens. So how do you figure out which oxidation state is which? Well, I think what you have to do for this is to separate your polyatomics. You have the ammonium ion, which is +1, and you have the nitrate ion, which is also, well, not also, but is -1. So you need to figure out the oxidation number, and you're going to do that looking at the hydrogen and the oxygen's oxidation numbers. So if I take a look at the periodic table, for hydrogen, there's only, it's hard to see, and I apologize, +1 or -1, and for oxygen, there's only -2. So we're going to use those clues. Nitrogen, there's a ton, so we have to figure that out. Okay, so if we go back, the overall charge for ammonium is +1. I have 1 nitrogen. I don't know the oxidation number. I got 4 hydrogens, each with a +1. In other words, I have X plus 4 is equal to -1. X is equal to, that's +1. X is equal to -3. So that makes the first oxidation state for nitrogen as -3. So it cannot be choices 1 and 2. Now I need to know, and let me erase all of this because it's getting really complicated here. For the nitrate poly, which is NO3-, now I need to figure out the oxidation state for that nitrogen. We got rid of these two. Well, I have 1 nitrogen, and that's X, plus I have 3 oxygens, each with a -2, and everything's got to add up to a -1, which is the polyatomic ion charge. So I have X -6, I'm sorry, yeah, X -6, which is equal to -1. X is equal to, I have +6 on both sides, so that's going to be, what is that going to be? That's going to be +5. Okay, so I totally messed up question 47. So let's take a look at question 47 again. I'm kind of starting over here. I had somebody knocking at the door anyway. And this question is not that easy. So for ammonium nitrate, which is NH4, NO3, all right, we have 2 oxidation numbers going for the nitrogens, which are different from one another. So how do we figure out which is which? Again, this is a tough question. So I could see a lot of students that in January would have gotten this wrong. If we take a look and separate out the polys, we have the ammonium ion, there's only 1. The ammonium ion has a +1 charge. The nitrate poly, there's only 1 in the formula, has a -1. So let's focus our attention on each of the nitrogens in each of the polyatomics separately. Okay, so when I have a polyatomic ion, the overall charge for the ion is what the oxidation numbers times the number of atoms that appear in the formula have to equal out. If I was to do the whole compound, which I would normally do, that would work except for one thing. Since I have 2 variables, I have 2 different nitrogens that have 2 different oxidation numbers, it's not going to work. So I have no choice but to separate them out. So let's take a look. I have 1 nitrogen in NH4. I do not know what the oxidation number is. Oops, so that's my X. Plus, I have 4 hydrogens, and for this, each one of these hydrogens would be basically giving or sharing an electron with nitrogen, but not equally. That would make the oxidation number for each of these 4 hydrogens is +1. So it's going to be 4 times +1. So now, down here, we have a math problem, not a chemistry problem. 1 times X is X, plus 4 times 1 is 4, and that's equal to +1. In order to get 4 over to the other side, I would subtract 4 from both sides, minus 4 and minus 4. So I get x is equal to, well, a minus 4 plus 1 is a minus 3. So I got a minus 3 for the nitrogen here. And then for NO3, oxygen has an oxidation number of minus 2. Everything needs to be equal to minus 1. I have 1 nitrogen. This again is x, what I'm solving for here. I have 3 oxygens, each one sharing unequally 2 electrons, or minus 2 for the oxidation number. So I have x minus 6 is equal to a minus 1. How do I get minus 6 over the other side? I do plus 6 on both sides. So x is equal to, this cancels, plus 6 minus 1 is a plus 5. So I got a minus 3 and a plus 5 and none of my choices. How could that be? Oh. Let's take a look at this. I totally had it wrong. It's NH4 NO2. So I need to figure out the oxidation number for this nitrogen and this nitrogen. Normally for a compound, since compounds are electrically neutral, meaning all the electrons balance out, it's set equal to 0. The problem is I got 2 variables here. So the only way that I can figure out the oxidation numbers for each of the nitrogens is to split up the polyatomics. So the ammonium ion on its own is NH4 with a plus charge. So let's go ahead and set this equal to plus 1. And what do I have? I have 1 nitrogen. I don't know what the oxidation number is. That's X. Plus, I have 4 hydrogen atoms, and each one is a plus 1. So I have X plus 4 is equal to plus 1. Now to get plus 4 over the other side and leave X alone, I got a minus 4 on both sides. So X is equal to, well, minus 4 plus 1 is a minus 3. So I know I have minus 3, so I can cross out choices 1 and 2. And then let's look at NO2. So this is NO2. This is nitrite. Originally I read that as nitrate, but of course you got to read, right? So for nitrite, the poly is equal to minus 1. Now, once again, nitrogen is what I'm solving for. I have X, I don't know the oxidation number. I have 1 nitrogen, plus I have 2 oxygens, each with a minus 2 oxidation state. Let's solve for X. X times 1 is X. 2 times a minus 2 is minus 4. That's equal to minus 1. I need to get X alone, so what am I going to do? I'm going to add 4 to both sides. So X is equal to, these cancel, plus 4 minus 1 is plus 3. So what do I have? I have a minus 3 and a plus 3, and I have a dog crying at the door, and that is choice 3. That, folks, is a pretty darn tough question. So if you struggle with it and you're having a hard time with it, I totally get it. That one was not easy. Let's keep going here, and let me erase all of this. Oh, I just erased the whole page. Let me see if I can get it back. Okay, let's take a look at 48. For question 48, it's talking about the hydronium ion, which is H3O+, but remember that that also is equivalent to H+ and water. So we have a table here, right? And what do I have? I have 4 solutions, and the concentration of this hydronium ion is decreasing from A to D. So it's asking which solution has the highest pH. Remember that pH values, the lower they are, the greater the hydrogen ion concentration. So the solution with the highest pH is actually going to have the lowest hydronium or H plus concentration, and it's going to mean it's going to have the greatest hydroxide ion concentration. So this is a little bit tricky, but the highest pH is going to go with choice D. Let's take a look at 49. We have a nuclear reaction. How do I know that? They told me that. Typically, nuclear reactions, you're going to see mass numbers on the top by the symbols, atomic numbers on the bottom, and you're asked to figure out what type of nuclear equation this is. Well, if we take a look, we have uranium getting hit by a neutron. It's forming a couple of nuclides that split apart. We get 3 neutrons out for every 1 we start with, and a lot of energy. So it's not going to be alpha or beta decay. With those kinds of reactions, you start with 1 reactant only. So it's either fission or fusion, and since we're splitting apart uranium, it is fission. Okay, the final question, question 50. Which nuclear emission has the least penetrating power and the greatest ionizing power? Okay, so what they're talking about are particles that would get spit out of the nucleus of an atom. Gamma rays are just energy. It doesn't mean that they're not damaging, okay, but it is energy as opposed to these others, which are particles. So, you need to know penetrating power and ionizing ability. Okay, so my alpha particle is the heaviest. Then I have my beta particle, which is beta minus. A positron is also called a beta plus. And then we have our gamma rays. As far as penetrating power, alpha particles have the least because they're the heaviest, and gamma is the most. As far as ionizing ability, meaning damaging our cells, alpha particles have the most, and gamma has the least. So they work opposite of one another. And your beta and positrons are always in the middle. Alright, so with that information, let me erase this. And let's take a look. Which nuclear emission has the least penetrating power but the most ionizing ability? That is going to be the alpha particle. And you might say, well, how do you know that? You just need to know it. It is a fact. So we are done with Part B-1. Part B-1 still had some facts on there. If we go back to page 1, it still had, knowing some definitions and what things mean. Here, like when I have a symbol dash a mass number, right? That tells me the number of neutrons and protons. But we had a lot going on as far as using reference table T in calculations. We had also a lot, though, that you have to recognize or memorize as far as types of equations. So the next video is going to be Part B-2, and then finally Part C. So the first 50 questions of the Chemistry Regents Exam are always multiple choice. Part A and then Part B-1. So on to short answer questions. Keep working hard and good luck. Please, if you like these videos, please subscribe to my YouTube channel. Check out more videos here. I've gone over other Regents exams. I try to categorize things by unit or topic. If you're having a problem, that you can go ahead and put some energy towards to make sure you understand things for the Regents, and just keep working hard and working through questions.